Okay, here we are in lesson 9.5 using the quadratic formula. So a couple things that we've done. We've been solving quadratics for a while, ever since we started learning about polynomials and our trinomials way back in chapter 7. When we took, here's the standard form, ax squared plus bx plus c. That's our function. When we make this equation equal to 0, we've been solving for x for quite some time, right? Say we have x plus 2 times x minus 3 is equal to 0. Well, then we know that x is either equal to -2 or +3 because of the zero product property. So that's our factoring. The disadvantage, some equations aren't very factorable. In lesson 9.2, we started graphing them. Actually, we started graphing in chapter 8. But then when we graph, we notice that the places where it crosses, we learned about this in 9.2, that it crosses the x-axis. These are those intercepts that we're talking about that actually right here. When we have equations in 9.3, we had, we could take the square root of both sides and we get our, plus or minus values. Certain equations work great for that. We are not even completing the square this year. You'll do that in high school. And then today we're going to learn to use the formula, and it'll work on any quadratic equation. All we have to do is identify what a is equal to, what b is equal to, and what c is equal to. It does take time, okay? So let's explore some of these things here. So we're going to use the quadratic formula. We'll learn about what the discriminant is to interpret it. And here's that formula. Here it is. X is equal to -b plus or minus the square root of b squared minus 4ac all over 2a. We have several songs. You can find them anywhere on the internet, but I found one that I thought kind of sing-songy here.
X is equal to -b plus or minus the square root of b squared minus 4ac all over 2a. X is equal to -b plus or minus the square root of b squared minus 4ac all over 2a. X is equal to -b plus or minus the square root of b squared minus 4ac all over 2a. X is equal to -b plus or minus the square root of b squared minus 4ac all over 2a.
Boy, that was something. All right, so let's take a look at using this. The main thing you're going to want to do is identify your A, your B, and your C, okay? So A is equal to 2. Here it shows you right here. Right here, it kind of shows you're substituting in 2 for A, -5 for B, and 3 for C. So we're just going to use substitution and then simplify. So 5 plus or minus the square root of 1, so that can give us 5 plus 1 divided by 4, or 5 minus 1 divided by 4. And we have two solutions then, 3 over 2 or 1. So we'll see about that in just a minute. Let's erase this. All right, number 1. So in this, it's already set up. I want to identify A is equal to 1, B is equal to -10, and C is equal to 16. Okay, so we have our X is equal to our -b plus or minus the square root of b squared minus 4ac all over 2a. And feel free to, my C almost looks like a exponent there. I don't know why. That's crazy. All right, there we go. Then we just substitute in. So we'll have -b. So we have the opposite of -10, right? Plus or minus, we'll have the square root of -10 squared minus 4 times 1 times 16 all over 2 times 1. So I'm going to kind of continue on down here. Sorry, number 4, you're getting the boot. Right. So we'll have a positive 10 plus or minus the square root of -10 squared is 100. 4 times 1 times 16 is going to be equal to -64. And then all of that is over 2. So let's simplify. We'll have 10 plus or minus the square root of 36 all divided by 2. So this is going to equal 10 plus 6 divided by 2, and it's going to equal 10 minus. Why is it X? I don't know. 10 minus 6 all divided by 2. So we'll have 16 divided by 2 here would be equal to 8, and we'll have 4 divided by 2 equals 2. So our solutions, we get x is equal to 8 and x is equal to 2. Okay. Why don't you pause the video and try number 2? Pause the video and try number 2. I know it's a lot. We'll skip number 5 here for you. We'll skip number 6 here for you too. Go ahead and pause the video. All right, when you solve this one, all right, you got down here and you probably got x is equal to, what'd you get? 2, and x is equal to -4. If you did not, you may want to recheck your steps. So 2 and -4. And then I'll go ahead and work on this one. So a is equal to 3, b is equal to -1, and c is equal to -2. So x is equal to -b plus or minus the square root b squared minus 4ac all over 2a. So we'll have, I'm just going to deal with that negative now. So we want the opposite of a -1, so we'll have 1 plus or minus. We're going to have -1 squared, which will be 1, and then minus, and then 4 times 3 is 12. 12 times -2 is a -24. And then put that all over 2 times 3, which is 6. Okay, so x is equal to 1 plus or minus. Well, when you take the opposite of -24, you're going to have 1 plus 24, so you'll have 25 and 6. So we get x is equal to 1 plus 5 divided by 6, and we get x is equal to 1 minus 5 divided by 6. So 6 divided by 6 is equal to 1, and -4 divided by 6 is equal to a -2/3. So here are our two values of x for number 3. That was number 3. Okay, so now we're going to look at the discriminant. So it says the expression that's under the radical right here. You can see the discriminant, b squared minus 4ac. It's the discriminant because it pretty much has all the power. It's going to tell us whether or not we're going to have any real or imaginary solutions. Because it's under the radical, we can use this value to determine the number of real solutions it will have, which is also the number of x-intercepts that the graph will have. So when we have greater than 0, right, we're going to have 2 real solutions. Let's see this. Look at this here. We'll have 2 real solutions, 2 x-intercepts, okay? When it is equal to 0, that means that pretty much the vertex is falling on the x-axis. You'll have 1 real solution and 1 x-intercept. When it is less than 0, okay, this is when you have this negative value under the radical. We do not have real solutions. We don't have any real value to understand, like what number times itself will give you a negative value. We don't have one. So there's no real solutions, no x-intercepts, and that's when the parabola will be kind of floating above the x, or if it's going down, it could be floating below. Anyway, so yeah, if we have the discriminant as a negative number at this point, in high school you will be dealing with that and being able to simplify it using the imaginary numbers. So for now, let's determine the number of real solutions. So we're going to use the discriminant right here, b squared minus 4ac. Okay, so if you have a 76, we know that it's greater than 0. You have 2 real solutions, 2 x intercepts. When you get 0, you're going to have one real solution, one x-intercept. So determine this. So we want to use the discriminant b squared minus 4ac. So we'll have 6 squared minus 4 times negative 1 times 3. So 36, and then we'll have 4 times 3, so we'll have plus 12. And 36 plus 12 is going to give us 48. 48 is greater than 0, so we'll have 2 real solutions. Okay, that also gives us 2 x-intercepts. Here, again, b squared minus 4ac. So when you substitute in, again, you'll get 6 squared minus 4 times 1 times 9. So 36 minus 36, we get 0. This is going to give us one real solution. This also gives us one x-intercept. So go ahead and do number 10. When you simplified it, you should have gotten down to a negative 26, and in this case, we have no real solutions, no x-intercepts, okay? This would be imaginary. All right, so finding the x-intercepts, same thing. Let's use the discriminant. So we have here negative, just going to do the whole quadratic formula here. B squared minus 4ac. So we're going to use the discriminant again. Remember, this is the whole x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And so if you're just asked to tell how many solutions or how many x-intercepts you're going to have, you could just work with that discriminant underneath the radical. So here, 4 squared minus 4 times negative 1 times 3. So 16 plus 12 gives you 28. And we know that we're going to have 2 x-intercepts, right? 2 real solutions, 2 x-intercepts, so forth. So I want you to do number 12. You've gotten 0, so you get 1 x-intercept, because that's what we're telling, the number of intercepts. Here, here we're going to get 64 minus 72 is going to give us a negative value, so no x-intercepts. All right. And that concludes lesson 9.5.